In this lecture, I'm going to discuss the concept of generalized mean value theorem, or we call it as Cauchy mean value theorem. So before going to start the Cauchy mean value theorem, let me recall the Rolle's theorem and Lagrange's mean value theorem. So let me define the statement of the Rolle's theorem. Suppose f is continuous in the closed interval AB and differentiable in the open interval AB, and the function value at x equal to a and b are equal f of a is equal to f of b. If the three conditions are satisfied for the function f, then there exists at least one point or one number c belongs to open interval AB such that f dash of c is equal to 0. So this is statement of the Rolle's theorem. So let us define the geometrical meaning of the Rolle's theorem. So in the coordinate system, so take a continuous nice function. This is y is equal to f of x. So this function is continuous in the interval x is equal to a and x is equal to b. The function is continuous in the closed interval ab, and the function is smooth, differentiable in the open interval ab. So the function is differentiable in the open interval ab. So derivative will not exist at the end points here. So and at x equal to a, this is a comma f of a, and this is b comma f of b. So f of a and f of b are equal. So then at least one point c in between the interval a b, f dash of c is always parallel to the x-axis. So here you can observe that here at x equal to c, tangent that f dash of c which is parallel to the x-axis. So this is the geometrical meaning of the Rolle's theorem. Now let me recall the Lagrange's mean value theorem. So this theorem is less restrictive than the Rolle's theorem. So let us define the statement of the mean value theorem. Suppose f is continuous in the closed interval AB, the function f is differentiable in the open interval AB, derivative will not exist at the point A and B. So here f of A and f of B need not be equal. So then there exists at least one point C belongs to AB such that f dash of C is equal to f of B minus f of A by B minus A. Suppose this is the statement of the Lagrange mean value theorem. If f of B is equal to f of A, then f dash of C is equal to 0. It leads to the Rolle's theorem. So here f of A is not equal to f of B. If f of a and f of b are equal, so that theorem leads to the Rolle's theorem. So let us define the geometrical interpretation of the Lagrange's mean value theorem. So let us take the function y is equal to f of x is a continuous function in the interval ab. So moreover this function is smooth, therefore the derivative exists at each and every point of the curve except at the endpoints. So this is the point a comma f of a, this is the point b comma f of b. So it take a slope at the point a comma f of a and b comma f of b. So this point is f of a. So this point is kind of that is the point f of b. Now, so this is right angle triangle here. So this difference from this point and this point, this is f of b minus f of a. So this point is b minus a. So ratio of f of b minus f of a by b minus a is the slope of the straight line from the point this straight line. So this must be is equal to at least one point between the interval ab. At this point you can observe that so this slope is tangent to the this line. So this slope represented by f dash of c at this point here. So this tangent is parallel to the slope of the straight line uh, f of b minus f of a by b minus a, that must be equal to f dash of c. So geometrically we can prove this result Lagrange's mean value theorem. So now we'll move to the Cauchy's mean value theorem. Suppose the functions f and g are continuous in the closed interval ab and they are differentiable in the open interval ab, and also g dash of x is not equal to 0 throughout the interval open interval a comma b, then there exists at least one point c in the open interval ab such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. So now let us move to the proof of the theorem. So first we show that g of b is not equal to g of a. So you have to prove that g of b and g of a are different. Suppose if g of b is equal to g of a, if I take, so then by Rolle's theorem, Rolle's theorem, there is a point, there is a point C belongs to the open interval AB such that g dash of C is equal to 0. So, but which is a contradiction, since you can observe that from the statement g dash of x is not equal to 0 any point in the interval AB, where C belongs to AB, so this is not possible. So therefore can conclude that g of b is not equal to g of e, since g dash of c is not equal to 0. So now we define a function f of x, that is f of x is equal to f of x minus f of a minus of f of b minus f of a by g of b minus g of a into g of x minus g of a. So this is a well defined function. So let us correct as equation 1. This is, since f of x and g of x are continuous in the interval closed interval a b, and they are differentiable in the open interval a b, so that we can conclude that f of x from equation 1, f of x also contains, since f of x is continuous and g of x are continuous, and f of x and g of x are differentiable in the open interval a b, so therefore you can write the function f of x is also continuous in the closed interval a b and differentiable in the open interval a b. So now let us check whether the f of at x equal to a and x equal to b are equal or not. So let us verify the Rolle's theorem for the given function 1, for the function f of x, capital F of x. F of a here at x equal to a for the equation 1, that is equal to f of a minus f of a minus of f of b minus f of a by g of b minus g of a into at x equal to a g of a minus g of a. So we'll get 0. F of a 0. F of a minus f of a get cancel. G of a minus g of a get cancel. 0 into anything is 0. At x equal to b, f of b is equal to f of b minus f of a, where x is equal to b, that is f of b minus f of a minus of f of b minus f of a by g of b minus g of a into at x equal to b, so that is g of b minus g of a. So g of b minus g of a into g of b minus g of a get cancel. So this is equal to f of b minus f of a minus of f of b minus f of a, remaining term here. So get cancel, we get 0. So therefore we can write f of a is same as f of b. F of x at x equal to a and b are equal. So therefore hence all the conditions of Rolle's theorem are satisfied satisfied for the function capital F of x. So therefore there exists at least one point C belongs to open interval AB such that f dash of C is equal to 0. So now let us go to equation 1 and differentiate equation 1 with respect to x here. So f dash of x is equal to here. F dash of x is equal to, here we have small f of x, that is f dash of x minus 0, that is a constant term 0, minus of f of b minus f of a by g of b minus g of a into g of x differential with respect to x, that is g dash of x minus 0. So at x is equal to c, we get f dash of c is equal to f dash of c minus 0, that is minus of f of b minus f of a by g of b minus g of a into g dash of c. So this, but here since conditions of Rolle's theorem f dash of c is equal to 0, so this implies 0 is equal to f dash of c minus f of b minus f of a by g of b minus g of a into g dash of c. So this implies f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of e. So this is the proof of the Cauchy's mean value theorem. So now let me define the geometrical meaning of the Cauchy's mean value theorem. So take a smooth function with parametrically defined here. So this point is g of a comma f of a. This point is g of b comma f of b. So take a slope points these points. So where this is x-axis intercept parametrically, this is y-axis here. So define the function x is equal to g of t and y is equal to f of t, where t varies from a to b. So when t is equal to a, that is g of a, and t is equal to for y, that is f of a, and for at the end value of the parameters t is equal to b, that is g of b and g f of b. So by using the parametric equation, one can trace this curve, this smooth curve. So this curve is differentiable now in the open interval AB and continuous function in the closed interval AB. So now this point here you can observe that at x equal to a means t is equal to a and t is equal to b. Yeah. So we can find the functions slope of this straight line here. So this point is, this is f of a, this point is f of b. So from this this is this point is g of a, this point is g of b. So g of b minus g of a, and this from this it is here f of b minus f of a. So slope of straight line is, that is f of b minus f of a by g of b minus g of a. So there exists a point C between the interval a b, such that you can see that there is a tangent. Tangent is parallel to the slope of the straight line. So therefore this can be written as, this is the slope, can be written as dy by dx. In terms of parametric you can write dy by dt by dx by dt. So where dy by dt is here, so that is x equal to g of t, that is dx by dt is equal to g dash of t, we can write here, and dy by dt is equal to f dash of t here. So this can be written as dy by dt can be written as f dash of t by g dash of t. At x equal to c, at x equal to x equal to t at no t is equal to c, sorry, t is equal to c. So this can be written as the slope can be written as f dash of c by g dash of c. Parametrically we can write that is equal to f dash of c by g dash of c. So this is geometrical meaning of the Cauchy's Menier theorem. So anyway, we can prove the theorem mathematically here by defining the function f of x here from this function here. So now we'll move to the note. We have Cauchy Menier theorem. It says that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. So this is the statement of the Cauchy Menier theorem. So it can be reduced to Lagrange's Menier theorem. If I consider, if I take g of x is equal to x, then g of x is continuous in interval a b, g of a is equal to a, and g of b is equal to b here. Now g dash of x is equal to 1, therefore g dash of c is equal to 1. Therefore the equation 1 reduced to f dash of c by, where g dash of c is 1, so that is equal to f of b minus f of a by, where g of b is equal to b, where and g of a is equal to a, that is b minus a. So this implies f dash of c is equal to f of b minus f of a by b minus a. So this is the Lagrange's mean value theorem. Therefore, so Cauchy mean value theorem is a generalized mean value theorem. So that can be reduced to Lagrange's mean value theorem by considering g of x is equal to x. So let us call this equation 2 here. Suppose if f of a is equal to f of b, function value at x equal to a and b are equal, then equation 2 reduces to f dash of c is equal to 0 by b minus a. This implies f dash of c is equal to 0. So this result leads to the Rolle's theorem. Yes. So we'll take an example. So verify the Cauchy Minier theorem for the functions f of x equal to x and g of x equal to x square in the interval -2 comma 0. Let us verify the conditions of Cauchy Minier theorem. So given f of x is equal to x is being a polynomial, and g of x, that is x square, is also being a polynomial function. So with the interval -2 comma 0. So we can observe the functions f of x is equal to x and g of x is equal to x square are being a polynomial functions are continuous in the closed interval -2 comma 0, and f dash of x is equal to 1 and g dash of x is equal to x. So it's a constant polynomial, it is a polynomial function. Again derivative exists in the interval open interval -2 comma 0. Also g dash of x, where g dash of x is equal to 2x, is not equal to 0 in the open interval -2 comma 0, so excluding 0. So g dash of x is not a 0 for the interval open interval -2 comma 0. So all the conditions of Cauchy-Minier theorem are satisfied by the functions f and g. So then there exists one point, at least one point C belongs to -2 comma 0, such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. So where a comma b is equal to -2 comma 0. So at x is equal to c, f dash of c is 1 and g dash of c is equal to 2c, and f of a is equal to f of -2, so that is equal to -2, f of 0, that is 0, g of a, that is equal to g of -2, so that is equal to 4, and g of 0, that is equal to 0. The substitute in this form. So therefore where f dash of c is 1 by 2c is equal to, where f of b is 0 here, so 0 minus of minus f of a is that is -2 minus of minus plus 2, 0 plus 2 by, where g of b is equal to 0, so -4. So this implies 1 by 2c is equal to minus 1 by 2. So this implies, so 1 by c is equal to minus 1. So this implies, so c is equal to -1. So -1 belongs to the interval -2 comma 0. Therefore Cauchy's mean value theorem is verified for the given functions f of x is equal to x and g of x is equal to x in the interval -2, 0.